Hello dear students, I am Samir Velankar and I welcome all of you to this first video in this series about pointers in C. Now pointers in C is found quite difficult by almost all students initially, but pointers in C is very important topic because it has great applications in computer science because it directly deals with memory of the computer. So let's see what is the definition of pointer initially. Pointer is defined as a variable. Now, this is a very important point. Pointer is a variable, don't forget that, which can store address of another variable stored in the memory. So basically, a pointer is something which stores address. For example, integer variable stores int value, or float variable stores some real number. Like that, pointer variable stores address. So let's first of all understand what do you mean by this address of the memory or address in the memory. So let's say that we have this memory. Now I am drawing a childish diagram. Really, this cannot be memory of the computer, but just imagine for some time that this is memory of the computer. So what is memory of the computer made up of? Now memory of the computer is made up of cells. It is made up of cells, and each cell over here is known as a byte. Each cell is known as a byte, and every byte can store some information. Okay, like what is human brain? Human brain is also memory. And what is human brain made up of? Human brain is made up of cells, and every cell is called neuron, and in each neuron we can store some information, or rather we store some information. And there are millions of such bytes in the memory, millions of such bytes. That's why we say that we have memory of 4 gigabytes or something like that. Now, because there are so many bytes or cells in the memory, each byte has been given a location number. Location number typically starts with 1 and proceeds sequentially. So you can see that location number of this cell or this byte is 5. This location number 5 is called address of that byte. So every byte in the memory has a unique address. For instance, there will be definitely a byte somewhere which will have address 100. So next byte will be 101 and the previous byte will be 99. The address of the previous byte will be 99. So that is what memory is made up of. Memory is made up of bytes or comprises bytes, and every byte has a unique address. Now let's see further. This pointer topic, I always teach by telling the students a very easy program, very simple program. And trust me, this program, which I am demonstrating now, is going to tell us almost everything about pointers. This is not an exaggeration, okay? This simple program is going to take us to the end of the chapter. Let's see what the program does line by line and understand what a pointer is. The first line declares an integer variable. You read this line as x is an int variable, isn't it? Having a value 10. Now, most importantly, any variable for that matter, any computer variable is always stored in the RAM, is stored in the memory. So this x also will be stored in the memory. But where will it be stored in the memory? Will it be stored here or at this corner or this corner? Where will it be stored? We really don't know where it will be stored. What operating system does is operating system checks the memory and finds a free place. Wherever it finds a vacant place, it will store x at that point. So let us imagine that x has been stored somewhere here in the RAM, in the memory. Now, why I have drawn this box is because I want to show that x has been stored in some bytes, because memory comprises of bytes, and x will exactly occupy 2 bytes of memory because x is an integer. Note, integer variable consumes 2 bytes, 2 consecutive bytes of memory. Now, basically, these 2 bytes depends on the system on which you are working. For example, the system on which I am working, every int variable, every int variable on my system consumes 4 bytes. So in the gate exam, if any example or any question on pointer is asked, they will clarify that int variable consumes how many bytes or float variable consumes how many bytes. But right now, let us assume that int variable consumes 2 bytes. So x has been stored at this point in the memory, here where I am pointing, but these bytes will definitely have some address. Let us imagine that the address of this byte is 100, so next byte is going to be 101. And the value, as you see, value of x is 10. Let's not question how is x stored inside these 2 bytes. Of course, it will be stored in the binary form, but I have loosely written x is 10 inside this variable x. So what do you have due to this line? Here is the line. What do you have? There is a variable x stored in the RAM at address 100 and the value of x is 10. Note that address of x is 100. We don't say address of x is 100, 101. We only say begin address of x. Begin address of x is 100. Now let's look at the next line. Check the pointer place. Int asterisk p. Now asterisk p over here means this is a pointer. Now any variable declared with the asterisk symbol, this symbol is called a pointer. So P is declared with asterisk symbol. So it's a pointer variable and it has a type int. Now every pointer has a type. Basically, every pointer has a data type, has a data type. So how do you read? How do you read this line? Just check this. Int asterisk p. P is a pointer of type integer. This way you read it. P is a pointer of type integer, or we say P is a integer pointer. So let's come to the line again. Int asterisk P. P is a pointer, then P is also stored in the memory. Now any pointer is also stored in the RAM, in the memory. That's why look at the basic definition on the top of the page. The definition says P is a pointer variable. P is actually, pointer is a variable. Check this. Pointer is defined as a variable. So any variable is stored in the memory. So we have P stored in the RAM and P will consume 2 bytes. Now basically P is a pointer of type int, isn't it? So, and you know that int consumes 2 bytes. So P will consume 2 bytes. Actually, at this point of time, it is very important to know that pointer always consumes 2 bytes. Whether it is int pointer, float pointer, double pointer, char pointer, whatever data type you give to the pointer is always consuming 2 bytes. Okay, we will learn more about this in the next videos. But right now you can understand that P consumes 2 bytes and this P itself will have address. So let's say P itself is stored at 2 bytes, 500, 501. And notice P is not having any value. We have not given any value to P, isn't it? Now the summary, the crux of this chapter, the core of this chapter, the point which I am now encircling over here, this one, P is equal to AND X. Now this line here, let's see, P is equal to AND X. Actually, this AND is the address operator. AND is called address operator. And this AND gives address of X. This address of X is stored by P. So hence we say P stores address of X. Look, I am loading P with 100 because address of X, very well seen in the diagram, is 100. So P stores address of X. That's it. That is what is a pointer. Pointer is a variable which can store address of another variable. And it's so easy to store the address. You just say on the left hand side of assignment operator pointer like P, then write equal to assignment operator, and then AND operator, and then the name of the variable. So like in this statement, P is equal to AND X means P stores address of X. Now, once this happens, once P stores address of X, then we say P points to X. P is a pointer to X. Now, I am sure GATE students know that in the memory there won't be any arrow or something. How there can be an arrow in the memory? This is just a convention. This is just a representation shown that if P is storing address of X, we say P points to X. Okay, let me clean the slate and let me draw this diagram again. Okay, what did we have in the memory? In the memory, we had X storing 10 in 2 bytes. X is integer, so it is 2-byte variable stored at address 100 and 101. Remember, we don't know where is X stored. We are just assuming it is stored at 100, 101, but definitely it will be stored at some location. Then there is a pointer called P. P is a int pointer, or data type of P is int, so it consumes 2 bytes. Anyway, any pointer consumes 2 bytes. I said that, but more about that in the next videos. And then P is equal to AND X. This statement, P is equal to AND X, means that P will store address of X, and begin address of X is 100. So P stores address of X, then P points to X. Now once this happens, if P points to X, if P points to X, then this notation asterisk P, if I write asterisk P anywhere in the rest of the program, then asterisk P means value of X. Value of X. So if P points to X, as you see P is pointing to X. Now if I write asterisk P in anywhere in the rest of the program, I will get value of X. Value of X is 10. You can state it in other words like this. Asterisk P means value to which P points. I repeat, asterisk P means value to which P points. Asterisk P means value to which P points, and value to which P points is 10, but that value is value of X. Okay, let's come to next line. Next line is printing X in %d format. Nothing extraordinary about it. So the first output of the program is going to be 10. Value of X is 10. The next line is printing asterisk P in %d format. But asterisk P means value of X. So that means that output is also going to be 10. I hope you are understanding, because P stores address of X. So asterisk P means value to which P points. That is, it is same as value of X. Now the next line is printing address of X. Check this, AND X we are printing. Check the cursor place. Now AND X means address of X, and we are printing address of X. But the format used over here is %u. Check the printf. We are using %u, and %u means unsigned format. We want to print unsigned integer. Now all of you understand that the address that we are printing is never going to be negative. You know, %d format is used for printing positive or negative numbers, because decimal numbers can be positive or negative. But pointer, that is address of a variable, cannot be negative. So you use unsigned integer format, %u format, for printing addresses. So the address printed over here will be 100, obviously, because address of X, begin address, is 100, as you see in the picture. Next line is again printing address of X. Read the printf. Address of X is %u, and we are printing P. Now you observe, we are printing actually value of P, and you all know value of P is 100. So 100 will get printed. Now the next line is really something interesting. We are printing address of P itself, and address of P, I'm sorry, this should have been %u. I'm so sorry. This is %u, because addresses are printed in unsigned integer format, and we are printing address of P, and P means address of P, and address of P is 500, as you see in the picture. So the output of the last line is going to be 500. Moral of the story is, it is so easy to declare a pointer. Just have a data type, then asterisk symbol and the name of the pointer. It is so easy to use a pointer. Just write pointer on the left hand side of equal to and right hand side become address of the variable, that is and x. And once the pointer stores somebody's address, then asterisk followed by the pointer name is the value of the variable to which it points. Okay, let's see the definition of this again. Definition of pointer is a variable which can store address. I hope now you understand. Pointer always stores address of another variable stored in the memory. Now, how do you declare a pointer? Check this. Pointer is declared with data type like int, then asterisk symbol, and then the variable name. For example, int asterisk p, you read this as p is a int pointer, or float asterisk x, you read this as x is float pointer, or x is pointer to a float, or you read it as x is pointer to a float value. Okay, how do you use a pointer? Now, suppose if you are having x equal to 10, int x equal to 10, you declare an int pointer p. And now this line is the crux. This is the core of the chapter I said. P is equal to and x means p stores address of x, isn't it? Now, if you read this statement, if p points to x, then the notation asterisk p means value to which it points, value to which pointer p points. That is, pointer p is nothing but value of x. That is, asterisk p is same as x, or we say asterisk p is alias of x. I really like this word alias. Now just be with this video. This is a very fundamental video on pointers. Now alias means another name given to the same person. For example, international criminals have aliases, or children have aliases. In home they are, or in house they are called something with some nickname, and in school they are called by their actual name. Now what is the alias? What I am talking about here? Now you see in this diagram, x is the name of the variable. Actual name of the variable is x, isn't it? Actual name of the variable is x, but once the pointer points to this variable, if p points to this variable, then asterisk p is same as x. Asterisk p is value of x, isn't it? So asterisk p is nothing but another name given to x. Just check this line again. I am marking it here. Just check this printf. Just check this printf. What are we printing here? We are printing asterisk p in %d format. But whose value do you get? You get value of x. Actually, for programmer, this is asterisk p. But believe me, internally C language will take this asterisk p as x. Asterisk p is nothing but value of x or simply x. I hope you got the definition of pointer. You have understood how to use pointer, more about the pointers and very much in detail, and lots of questions are coming up in the next video. Thank you very much.